Hiya students, here we go again. OS3, this is number 7. Now you were probably cruising along through some of those other exercises 1 through 6. Maybe some of them were a little tricky. This one is a little bit more challenging and it's definitely more steps. So let's spend a few minutes with number 7, okay? First of all, I actually wrote out the skeletal structures for the reagents to make sure that I know what they are. Here's my product. Wow, okay. So we're adding things to benzene. So I know we might want to review electrophilic aromatic substitution, right? That is this puppy. So if you're not sure, check those out. We're gonna do a little retrosynthesis, right? So we're gonna start at the end and work our way backwards a bit. So, how did we make this? We've stuck 2 things on benzene, first of all. One of them is just an alkyl group, which implies alkylation. One of them is an acyl group, or piece, so that implies acylation. So I know what we had here was something like our benzene, and this was probably something like this. And we add the appropriate catalyst for alkylation. And over here, this one was probably something like, yoink, yoink. And remember, acylation involves this unusual group, right? This acid halide, or acyl halide. So these are the pieces that I added. You don't add them simultaneously, you add one and then the other. So when you're thinking about the final assemblage, you have to remember to look to see what isomer we're talking about, okay? In terms of ortho, meta, or para, here we have what final product, right? This is the para product. The para product means that whatever we add first had better be, that's right, an OP director. Only one of these groups is an OP director. Which one is the OP director? Right? This one. The alkyl group, carbon groups are OP directors. That's actually a meta director. All right, so the first thing to add is the director. So when we do this final assembly, we're going to want to do this first, followed by this. Okay, so that's the end. Now, to go back to the beginning, we got to think about how we can make these 2 pieces. Right? So here's what we're starting with. One part of this is fairly straightforward and the other piece is tricky. The one that's fairly straightforward is the one here in red. We can make that in a couple of steps from this one, right? So we can do, for example, let's write that here. We can oxidize this using our powerful oxidation. That's dichromate in acid. And we didn't talk about this a lot, but there is that reaction to convert this to an acyl halide. It involves adding this. That's that secret agent reagent, the SOCl2. It does a couple of different things, but one thing it does is essentially it makes this. So starting with 1-propanol, we can make this piece in just a couple of steps. The trickier one is this one, and what makes that tricky? Well, how many carbons are we talking about here? We're talking about 2 carbons. Uh-oh. And which of our reagents has 2 carbons? None of them. In fact, these each have 3 carbons. If we have something with 3 carbons and we got to whittle it down to 2, that means we have to, right, bust it apart. So we're going to use the only reaction that we learned that will break carbon-carbon bonds, right? And that would of course be alkene oxidation, which means we need to make one of these into an alkene. One of them is much easier to make into an alkene than the other. This one being primary does not easily do elimination. This is the one that does elimination, right? So in our second step, we're going to start with this. How do we eliminate an alcohol? It's not OH minus, okay? OH minus is eliminating haloalkanes. That's an E2. This one we're doing E1, which means we need, you can just write H plus if you want. If you don't, if you want to be more specific, you can write H2SO4, sulfuric acid. Either way, that's going to make this. Now we gotta bust this apart. The buster aparter is potassium permanganate. Which flavor is the cleave in half? That's right. We've got to use, oops, I wrote acid. No. There's nothing better than I love, other than Coca-Cola Cherry Zero, than a big steaming cup of hot acid. That's gonna break this clean apart. And we're gonna make this. And these are both going to be primary after they come open, so they're both going to be acids. Under some circumstances, this gets oxidized all the way to carbon dioxide, but you can just leave it as that for now. Now, this is actually pretty close to this. We can convert the 2-carbon acid into the 2-carbon haloalkane in 2 steps. First, we need to reduce this. Some powerful reduction with lithium aluminum hydride, bam, to an alcohol, and then this is just a little SN2 magic with some HCl to get us this, woo, and then we're done. That was a tough one, and you know, a lot of you, even if you weren't able to get sort of the whole way through, you probably got some good work on that, right? So again, a couple things that were really helping us. Number 1, think retrosynthesis. That's super helpful. Number 2, count your carbons, right? And think about which carbons here turn into which carbons here. Then know that if you have to alter the carbon skeleton, we're talking about alkene oxidation in this case to bust things open. All right? Good job on that one. That one was tough.